Hello everyone, good evening, Assalamu alaikum. This is MD Hasan Riaz. I'm doing Bachelor of Mechanical Engineering at UTHM. Right now I'm going to present about my final year project 1. The name of my final year project is Improvement of Vortex Induced Bladeless Wind Turbine, and my matric area number is AD18002. My supervisor is Dr. Sofian bin Mohammed. My panel number 1 is Dr. Noor Adrian bin Noor Salim, Dr. Mohammed Faiz bin Ramli, and Dr. NC Zarif Hassan. Background of study. Energy is the important and demandable for the daily activities of human beings. The industrial development of a country is depending on the energy generation and proper utilization. We all are bounded with the energy. The energy supply is determined by the available renewable and non-renewable energy sources. Non-renewable energy supplies are rapidly depleting. Thus, the global need for renewable energy sources are substantial and increasing. In recent years, wind energy has been one of the most important contributors to the increased efficiency of renewable energies. Although the wind turbines are effective energy harvester, but the construction and maintenance costs are higher for the setting of large-scale windmills. There are also some environmental hazards such as noise pollution, bird strikes, excessive vibrations, and etc. So to battle these problems, there is an alternative way to converting wind energy into electrical energy. This is such as vortex induced vibration. Problem statement. To generate electricity, there are hydroelectric plants, heat electric plants which are running by coal, but it's not environment friendly as it increases the global warming. Aside from being a non-renewable sources that can be used up soon, so that an alternative way has been created to generate electricity by harvesting wind energy using wind turbines such as vortex induced vibration devices. Conventional wind turbines need high velocity of wind to generate electricity. It can reduce birds' lives. Thus, small vortex-induced vibration wind turbine is preferable as it can generate electricity in low-speed condition and can be set up in a small place. A prototype of vibration vortex-induced bladeless wind turbine is fabricated at UTHM, which couldn't generate electricity. Research objective. The objective of the research is to investigate the electricity generation system of the functional prototype of vortex bladeless wind turbine, and the second objective is to evaluate the power generation performance of vortex bladeless wind turbine and its future development. The scope of the study is the investigating the design prototype of functional vortex induced wind turbine, finding out the electricity generation system of the prototype and collecting the previously tested data, then analysis of electromagnetic induction system, flux coil, cutting velocity, magnetic flux, etc. And conduct wind turbine testing, airflow, frequency, wind speed, windshield, vortex presence, etc. And then conduct a wind turbine test. And now, significance of a study. In the significance of study, this study enables improvement of the vortex-induced bladeless wind turbine in terms of developing electricity generation system. A typical windmill is massive and they must be spaced far apart. As the bladeless wind turbine is compact, the size of wind farm may be low and they can be placed close together. This study exposes us that bladeless wind turbine can also be utilized in the metropolitan city areas as it can work in the low speed condition. It can be used in the highway as alternative power source of light. This study may be a source for knowledge on the developing of vortex induced vibration and its parameters and electricity generation system for future researchers. In this picture we can see a vortex bladeless wind turbine. A vortex bladeless wind turbine is a kind of turbine which can generate electricity from the wind. First of all, the mechanism is it converts the wind energy into kinetic energy and then kinetic energy to electric energy. So in the literature review, the vibration energy harvesting systems are classified in 4 characteristics like such as electromagnetic, electrostatic, piezoelectric, and so on. This vibrational wind turbine design represents a new geometrical concept in wind energy and contributes to the eradication of the current difficulties associated with huge traditional windmills. Detailed experimental studies have shown that At large vibration, the vortex decoupling pattern can be changed from 2 typical vortices per cycle to 3. Here we can see the vortex shading. Right now, the vortex induced vibration is a result of vortex shading phenomenon, which generally occurs nearly on any bluff body when submerged into a fluid flow. Normally, irregular vortex shading will be occurring flow behind the body, resulting in the fluctuating pressure differential, which produces lift force perpendicular to the direction of the flow. The oscillating motion on the body is due to the alternating lift force. From the oscillation, it can harvest the electricity. This is the literature review summary of previous study on the bladeless wind turbine. From here, the noticeable thing is that from that 4 study, there was only in one topic numerical study on uncontrolled and controlled cylinders has been expressed the vibration wind turbine force and power, and others they didn't study about the forces. And there they use the piezoelectric material, and another one is the permanent magnets. Lock-in frequency. A phenomenon known as lock-in is a condition when the vortex shading frequency becomes close to the natural frequency of the body. It has the potential to enlarge the amplitudes of bodies oscillation, which is similar to linear resonance. To further complicate things, studies reviewed by Govardhan have shown that the range over the lock-in occurs has a strong dependence on another non-dimensional parameter. For large values, lock-in ranges does not vary significantly as the oscillating mass is changed. The magnetic force is inversely proportional to the square of the average distance between the poles. With the added magnet, the frequency of oscillation is directly proportional with the oscillation amplitude. Here we can see the tuning system, or this can be called as the lock-in system. Different types of vortex bladeless wind turbine. In this picture, there are 4 shape wind turbine is classified. The first one is flexible circular cylinder, the second one is flexible conic cylinder, the third one is solid circular cylinder rounded on the flexible surface, and the last one is solid conic cylinder mounted on a flexible surface. In the flow of methodology, first step is to investigate the prototype of bladeless wind turbine and its parameters and its electric generation system. Next, find out the problems of the prototype and point out the electrical circuits designed harvest and wind to harvest the wind energy. Then develop the systems and work on the generating and storing the harvested energy. Afterwards, the prototype will be tested in the environment and analyzing its capability and efficiency, whether it's working or not. And then the output will be vortex shading frequency, natural frequency of the mast, the amount of power generated by the system, and lifting force, magnetic flux, etc. This is the workflow process of the final year project. The first part is about the PSM1, and the second part is about the PSM2. First part includes the topic, literature review, and the methodology. Second part includes about the results and discussion. The first is to investigate the electrical generation system of the prototype. So for this, there is 2 pictures. In the 2 pictures, first picture is the cross-sectional view of the bladeless wind turbine, and second one is the fabricated one. So for the improvement of bladeless wind turbine, there was thorough study and investigation had done on the fabricated vortex bladeless wind turbine. Here the study have been about the physical properties, functional properties, electric generation system parameters had been studied. Then analysis was taken into to find out the problems and failure of the electricity generation system. Here we can see the physical and geometrical properties of the VBWT. There are around 14 parts: the base plate, base body, and parts materials. Then the term, then the physical properties: model diameter, length, mass, stiffness, natural frequency, air temperature, air pressure, air density. By using the table, the natural frequency of the body can be calculated, and the vortex shading frequency also can be calculated. Here the natural frequency is 3.52 Hz, the vortex shading frequency is 1.74 Hz. but for achieving the resonance, the natural frequency and vortex shading frequency should be same, but there is not same. So resonance will not occur in 1.86 meter per second speed. Electromagnetic induction system is advanced system to generate electricity. So here the magnetic induction operates by using a coil of wire that must be cut line with Faraday's law by a magnetic flux to create current to the mast. Coils of copper wire are attached on the bladeless wind turbine to make it operate. Here the coils. The installation of the stiff rods. After that, a magnet is attached to the mast above the copper coil. When the mast vibrates, it generates AC current. It's a key element that may impact the quantity of the generated in the power. Here this is the previously tested data of vibration of bladeless wind turbine, and the mass frequency is 3.10 Hz when it is tested, and the vortex shading frequency is 2.83 Hz. So from that, the respectively the resonance will occur from 3 to 4 meter per second wind range. Findings from the investigation, it can be summarized that the electromagnetic induction system failed due to the lack of resonance, as the frequency of natural frequency of the mast and the vortex shading frequency is not same, and then copper coil design was complicated, thus the coil could not be located in the designated place. Afterwards, the number of turns of copper coil became insufficient and magnetic strength was very less for this thing, and magnetic flux strength, coil inductance, force, power, electrical kinetic power not defined, so it was not possible to evaluate the power generation capacity. So preliminary steps and results. In improvement of vortex induced bladeless wind turbine, a mathematical modeling has been developed to evaluate the power generation, lifting force, kinetic power, power density, etc. A sustainable high stress stiffness is calculated under resonance condition to improve the design model. So here we calculate the stiffness with this equation. Then the magnetic flux phi equals to B A cos theta Tesla has been developed for the system. Electromagnetic force or induced voltage has been also determined by following this equation. Then coil inductance is determined. Then after that, design of the coil holder, copper wire, magnetic flux has been improved. Next, kinetic power, electrical power, power density has been defined. Here a numerical and a mathematical model was built to calculate the force and the vibration of the variability, which can be used to calculate the power of the vortex bladeless wind turbine. The vortex shading creates a transverse strain on the mass that moves back and forth. This is a more aggressive force if T, because it is a sinusoidal process. It is feasible to represent it as a time harmonic at the shading frequency. In this picture, the K is the stiffness, C is the damping ratio or drag force, and M is the mass, and F is the force, and this is the formula. Magnetic induction system development. As there was problem, so we had to develop the magnetic induction system. The coil holder, here we have developed the magnetic induction system. The coil holder is redesigned to make the more turns of the copper wire and place it in the right location, and then copper wire should be the thicker than previous one. So our previous one was 0.8 mm, and right now I have taken the 0.2 mm, and then the number of turns was 40 to 50 turns. Now I have taken the number of turn is 70. To increase the strength of the magnet, initially there was 3 magnets. Right now initially I will take the 6 pieces of neodymium rectangle ferrite magnet for the magnetic strength. Through this, the magnetic induction system can be updated. And the preliminary results. In the preliminary results, I can say the kinetic power of wind can be calculated from this formula, and after we got the kinetic power of the wind, which is 0.14 watt. The electric power, what is electric power? Electric power is the rate of electrical energy transmission by an electric circuit per unit of time. The weight denoted The watt denoted by the by P and measured using the SI unit. This is the formula of the electrical power. Power of electrical is to V square over R. Here V square is the induced voltage, R is the resistance, and the wind's power density. Then another thing is the lifting force. In the preliminary result, we got the lifting force. Through this formula, we got the lifting force, and the lifting force is 0.15 Newton. These are the preliminary results of the methodology study. To evaluate the bladeless wind turbine, a wind tunnel is necessary where wind speed condition can be maintained. Next, the bladeless wind turbine can be tested in the nature, and that's all. Conclusion. In conclusion, I can say that the brief explanation of vortex induced bladeless wind turbine, vortex induced vibration phenomena, power generation system, other elements expressed on the literature review. The electricity generation through electromagnetic induction system, magnetic flux, power density, resonance, vortex shading, natural frequency has been analyzed. The concept of improvement of bladeless wind turbine is chosen based on the investigation, and that's all. Assalamu alaikum.